Hello and welcome. This is the first edition of the Stats Detectives. I'm Tripp Babbitt, and on me, along with Dr. Frony Ward, will be looking in this particular episode at Paul Krugman's New York Times article from January 28, 2018, What the Economic Data Don't Tell Us. We're going to take a look at gross domestic product, or GDP, versus the unemployment rate. This is a long video, so for your convenience, we've put some time markers down in the YouTube channel so you can skip to whatever sections that you would prefer to watch or start with. So the 5 areas are why we made this video. The second area is Dr. Krugman's graph that he uses in the New York Times article. The third is a reinterpretation of that graph by Dr. Frony Ward. And then the fourth area is using statistical process control charts, or as I like to reference them as control charts, something that is not used very often in looking at economic data or business data or really any data. And it's something that we feel that people should be using. The fifth area is going to be the conclusions that we came from looking at these data from this article. We hope you enjoy it, and we look forward to providing more in the future. First of all, tell me why you honed in on Paul Krugman's article. What was it that attracted you to Paul Krugman's article?
I regularly read Paul Krugman's articles because I find his explanation much of the time about economic situations. I find his explanation tends to be clear. I feel as if I understand what he's talking about. And so I've read a lot of his articles, and this appeared on a Monday in January, last Monday or Tuesday, typically in January. He's a New York Times. Paul Krugman is a New York Times editorial columnist.
Okay.
And he is a Nobel laureate. So, in some sense, he's got some credibility. So I read his article, which had to do with GDP growth being a hot topic in some ways amongst the folks who are concerned about the economy, and the change in unemployment. So GDP growth and change in unemployment. For whatever reason, this was again. And there were 2 graphs in the article. He said, another thing that captured my attention was the article was saying what the economic data don't tell us. So all of a sudden I was all caught up with it, because what the economic data don't tell us. And I'm suspicious of what data tell us anyway, so I like to get my hands on it.
Okay.
So anyway, I read that, and I guess the best way to say it, Tripp, is that I was disappointed.
Okay.
Not that I didn't agree with some of what he was talking about. Now, I'm not an economist, for one, so that's a big admission. I am a statistician. I'm darn good at that, but I'm not an economist. So I was looking at his presentation to support what he was trying to say. And he had 2 graphs, one from an organization called FRED, which is an organization I've got been exploring. And then one that was supposedly explained how he was going to say that GDP growth was not going to hit 3%. Mm-hmm. Now, GDP growth hitting 3% is something people have been holding out as oh my gosh, this is great. We're hitting 3% GDP growth. And the latest number turned out to have been about 2.4, 2.6% in December. So, the number for all of 2017 was about 2.4 and at the end of that 2017. So then he shows a graph. He says we're not going to hit 3%. And he shows a graph that was not sufficiently labeled for me to be able to understand it. And when a graph is not sufficiently labeled for me to be able to understand it, I'm suspicious of that graph simply because I've got a good deal of experience in putting together graphs that I work hard so that people will understand them. And particularly, this graph had to do with a principle called Okun's law.
Okay. It's an economic principle, I'm guessing, of some sort.
Yeah, an economic principle. And what was fascinating to me was that he actually said, I'll quote from the article, he said, talking about the economy's productive capacity as summarized by perhaps GDP growth. And he said the unemployment rate is an imperfect measure of idle capacity. Still, there is a strong relationship. Now, this part really got me. Strong relationship, whatever that means. Okun's law between changes in the unemployment rate, that is, he says, capacity going into or out of use, and short-run economic growth. Now, not understanding all the terms and not being particularly able to understand the graph he provided, I did a bunch of research. And I discovered that Okun's law is an empirically derived law. I did not discover any measure of that relationship, so I don't know why he calls it a strong relationship. You know, he says strong relationship but doesn't quantify it. I don't know what a strong relationship is. Now, in the statistics world, there is a measure of relationship. Technically, it's called a correlation coefficient, and it tells you whether a relationship is strong or not.
Okay.
But he did not provide any evidence of the strong relationship. And the other part is that this Okun's law, I mean, it's spread out over, I don't know how many years of derivation went into it. But Paul Krugman, in this particular example, showed only 11 data points. And if you look at the graph, it's quite obvious that 9 of the 11 cluster in one spot and the other 2 are off to the side. Well, that brings up another issue. Analysis of data, when you have a cluster of stuff in one place and 2 data points somewhere else, indicates that those 2 could well be anomalies of some sort, not part of the general picture. He did not provide any kind of identification of those 2 data points, so I went back and I recreated his graph.
Okay, so this is the, just for my benefit, there's 2 graphs on his page. You're referencing now the second one, the one called Okun's Law, 2007 to 2017.
That's right. And on his graph.
Yeah, and on this graph, you've got GDP growth on the vertical axis, and on the horizontal axis, you've got change in unemployment.
That's right.
Okay. And so there, then you see you see 9 of the points pretty well clustered together around what, 2% GDP growth and
yeah, somewhere around about 2.1% GDP growth and about negative change in unemployment, meaning unemployment was going down. It was about a negative 0.6. So the intersection of these is about a negative 0.6 change in unemployment, and that means that the unemployment is going down, which is the direction you'd like it to go.
Okay.
And the GDP growth is going up. The other thing, a couple of other things, he identified one of the data points, but he did not identify all of them. Mm-hmm. GDP growth is the change from one time period to the next, but did not identify what those time periods were. And change in unemployment is obviously the difference between 2 numbers. And so I finally found what those were. And as it turns out, the change in unemployment I know it's on the graph itself. Change in unemployment is the change in the average unemployment from one year to the next.
Okay.
If you go to a source, and I use the Bureau of Labor Statistics, and you get the unemployment data values, you get an average for each year, which is a kind of a strange reference point, but you get an average for each year, and then you look at the change in the average for each year, and that's what change in unemployment was.
Okay. So it's basically taking, because it's reported monthly, correct?
It's reported monthly, but
so
you get the
so then you would have 12 data points, and then whatever those added up, the sum of those then divided by 12.
That's right.
Okay.
That's right.
Okay.
Contrast that with the GDP growth, and the GDP growth is the difference between December of one year and December of the next year.
Okay. All right.
You have monthly values on GDP growth as well.
So does he explain that in his article, or is that something you just know because you know the data?
I know because I got the data and worked with it. I looked from one December to the next, and that didn't work.
Okay.
For the unemployment.
Mm-hmm.
And then I ended up having to get so once I got all the data, originally I used the data that came up from the Bureau of Labor Statistics, and it did not match the graph in his paper at all.
Okay. Why?
So
why is that?
Well, because I was looking at the difference in change in unemployment from December 14 to December 15, December 15 to December 16, December 16 to December 17.
Okay.
He was doing it from the average unemployment for 2014 to the average unemployment for 2015 to the average unemployment for 2016. So the numbers were not the same. GDP growth was the difference in one December to the next. So the actual use of the data was different in these two different data series. The way he referenced unemployment change was from average to average to average. GDP growth change was December to December to December.
Okay.
So it took me several hours to get the data, finally figure out what he was doing, and make a graph that looked like the one that he had.
Okay. And is there any reason why he would have done that way?
I have no idea.
Okay. I didn't know. I was just curious as to when if it took you several hours to come up with the same data, and it doesn't match the Bureau of Labor Statistics, it just.
Well, I did originally. Ultimately, actually, I could not figure out how to get the GDP growth from the Bureau of Labor Statistics. I ultimately had to get it from a website called Statista.
Uh-huh. Yeah, it's a German firm.
And so I got it from the website called Statista.
Uh-huh.
And that worked pretty well. And so it took me different sources, playing around with the data to be able to get the graph that he had.
Okay. So you were able to basically match it up. I was just curious of why your speculation on why he might have done it that way.
Yeah, well, to tell you the truth, I don't know whether this is, I do not know why he did it that way.
Mm.
I suspect that Paul Krugman is a fairly busy person.
Mm-hmm.
And I suspect that in the world that he lives in, he probably relies on some people to help him put his
numbers together.
Okay. And said, okay, here's a graph. Here, I want something that shows Occam's law. Use this data, whatever. Mm-hmm. And he did.
Okay.
My concern is that when you.
So he did, but it's not sourced in the article.
No.
How he did it or where the numbers came from.
It is not sourced in the article where it came from. It was not sourced on that graph. I've got a copy of the article that I took just copying the whole article and putting it in a Word file, and there's no source.
Okay.
There's no reference.
Okay.
There's no reference to what Okun's law is.
Okay. All right.
So I had to go find that one too.
All right. So tell me what you did wound up doing with these data.
Okay. What I wound up doing with the data, I looked for change in unemployment. I looked for GDP growth. I found them in two different sources, one Bureau of Labor Statistics, one in Statista.
Mm-hmm.
And I ultimately played around with the data, as in I did calculations, I did all kinds of things to get a plot that was identical to what his was, to get a graph that had data points in the same places that his did.
Okay. And I see that. And then it looks like then you put each of those into statistical process control charts or process behavior charts.
Ultimately, but even before I did that,
okay.
Tripp, what I did with the graph I made of the Okun's law,
mm-hmm.
what I did is I put a definition under the axis where Paul Krugman said change in unemployment. I put the actual definition, what change in unemployment was, underneath there.
Uh-huh.
And I put the source.
Okay.
And for the GDP growth, I put the source.
Okay. I got you. Okay.
I also identified all of the data points by year, not just the most recent one, but all of them by year.
Mm-hmm.
And then, as you're right, two more things I did with that particular graph. Paul Krugman had a line that went through the 11 points.
Okay.
That connected the clustered of 9 points, the upper left-hand corner cluster of 9 points with the two.
Uh-huh.
I put the actual equation of that line on there, which doesn't quite match Okun's law definition. The other thing I did was take the two data points, and they were for 2008 and 2009. I took those two data points and I said, okay, these are not really indicative of the rest. So 2007, and then 10, 11, 12, 13, 14, up through 2017 form a cluster. And so I did the best fit straight line through those.
Okay.
And that is almost a flat line. There is no statistical relationship amongst those.
Mm-hmm.
And so that actually leads to the concept that the best predictor of GDP growth based on those data points would be the average, somewhere around 2.1%.
Okay. So you treated the 2008 and 2009 points as outliers.
I treated them, I don't like to use the word outlier. I treated them as indications of a different phenomenon.
Okay. And what does that mean? It
means that something different was happening in the economy, to my mind, and I think it bears out by looking at what happened to the economy at the housing crisis and subsequent years, starting in 2008, and then taking until 2000, probably close to 2012, 13 for a recovery. But as far as the data here on GDP growth versus change in unemployment. Now think about this. The horizontal axis is change in unemployment. It is not unemployment by itself. Mm-hmm. It is an indication of how much unemployment has changed from one year to the next.
Right. Okay. Yeah, you're right.
So change in unemployment could be, a steady decline while GDP growth is staying at about the same amount.
Okay.
Unemployment is changing, but the speed at which it's changing is a steady one.
Okay.
And that pretty much is borne out by other graphs that I've looked at.
All right. So
I don't quarrel with Paul Krugman's conclusions that it is unlikely we're going to hit 3% GDP growth based on the current economic data. That part I'm completely in agreement with him. I don't think his argument is best made by the graph he put out there, nor the way the data were analyzed.
Okay, so if we were to put this in layman's terms,
Uh-huh.
from my perspective, it would be based on the models that we have. We've got this phenomenon in 2008, 2009 that was caused by something, changed the system, if you will.
Yes.
And then you've got a bunch of clusters of everything operating in the same way. I guess the question I would have would be, and he's refuting the fact that we can achieve the 3% within the current system, the way the current system is doing. So with the tax cuts that we just got, or some of these different factors, we'd have to let the data bear out to figure out whether those are actually going to have the effect of increasing to 3%. You can't base that off of the existing system.
That's exactly right. And so the current, that particular current cluster of data points, 2007 and then 2010 through 2017, are not indicative of what's going to happen in the future. Here's one of the issues that I think does not come across really well in much of the discussion of economics or even any other phenomenon that people are using data as a framework for which to get messages, analyze what's going on. And that is that the data that you have are indicative of the current context. They're indicative of the current
system.
Dynamic system. Yeah. Exactly right. They're indicative of the current system. Should that system change, that the changes may indeed indicate a difference in GDP growth or unemployment or whatever.
Because we can't extrapolate the existing data that we have to then say it's the same as the old system. And I guess then the question becomes, are the changes being made, if we're looking at today with the tax cut that we received, one, is that enough of a different system that it's going to make itself like 2008 and 2009 in some way? Or is it associated with a big enough difference that it is a new system, and therefore the existing data for all these years that we're looking at, 2007 to 2017, are not a fair comparison?
I'm so glad you asked that, or I'm so glad you posed that, because given that anything that happened subsequent to 2017, and the tax law at the end of 2017 hasn't had time for us really to collect much in the way of data to indicate what's going on. One, the data we have are not, they're not going to be usable for making predictions under changes.
Okay. All right. And I think that's important. Okay.
And secondly, the only way we will know what happens with those changes is if the data we get do change.
Okay.
Like the 2008 and the 2009. That brings up the other part of the paper, which is, how do we know when the data tell us a change has happened?
Okay.
And that was a beautiful way to bring it up. If you go to the two graphs I have, one is...
So now we're looking at the process behavior charts.
Now we're looking at the process behavior charts. And this goes back to, I'll put in a little comment here. Much of the analysis of economic data is done by looking at models that will explain how the data behave based on traditional statistical analyses that try to form predictive equations. Modeling the data. Let's study the data, and typically modeling the data is done through the most familiar to people who have had some statistical background is a regression analysis. The regression analysis has been around a long, long time. There are basic regression analyses like a straight line. There are some more complex ones that have some curves to them. And then there's quite a bit of regression analysis. But the whole purpose is to create a model of what the data are trying to tell us, and then ask the question, how well does that model predict what we've got and then potentially the future? One of the difficulties in any of this business of creating predictive models out of the data we have is that the data we have may or may not be indicative of something that is the context of the data may have a lot of anomalies to it that we're not taking into account.
Okay.
And another way of looking at data, particularly data over time, is through the technique that Walter Shewhart developed in the 1920s as he was looking at the way the output of manufactured product behaved according to various characteristics. And then W. Edwards Deming picked up and thought that was just an amazing way of looking for signals. And I call them signals, things that are departures rather than outliers, signals that something else is going on. So particularly with overtime data, I use Walter Shewhart's approach. This is called an individuals and moving range chart. And what it does is rely on subsequent differences in the data. If we're plotting yearly data, the year-to-year differences become our background noise. And that is the randomness or the part of the variation that we cannot attribute to any particular phenomenon. And then we ask ourselves, has something else occurred? Has something else occurred that sticks out? And if you look at the change in unemployment, the data from 2007 to 2017, you will see fairly easily in the first part of the graph, you will see that the change in unemployment is rising and goes rather high up above what the change in unemployment, looking like it's about at a 2.5% to 3% change in unemployment in 2009.
Okay. And this is still using the Krugman kind of data that you looked up.
Exactly.
Okay.
It is still using the data that he used for the horizontal axis of his graph.
Okay.
Change in unemployment, those are the same numbers.
Okay.
The change in unemployment, change in the average from one year to the next.
All right.
And you also see in that first part of the graph, you also see that starting in 2010 and going on down, the change in unemployment, not the absolute value of unemployment, but the change in unemployment drops.
Okay. That you're talking about the
right. The
the moving range chart.
No, I'm talking about the individual numbers.
Oh, the individuals. Okay.
3, 4, 5, 6. There's 7 of them.
Yep.
From 2011 to 2017, down below the average.
Okay. Yep. I see them.
So I said, okay, let me take those. Actually, I used 2010 as well. After the phenomenon of 2009, I said, okay, let's just look at those last 7, 8 years. Mm-hmm. And you will see on that graph that indeed the change in unemployment dropped to a negative 0.75, I think it is.
Yeah, 0.76.
Negative 0.76,
Uh-huh.
yeah. Indicating that unemployment is going down steadily.
Okay. So what are let's see, we've got an upper control limit. What is that number? I can't read it because that one outlier for 2010.
Yeah, no, it isn't.
Yeah.
It's about a 3.
A positive?
No, it's right at 0.
Okay.
Or just a hair above 0.
All right. So what we're saying is that we could expect anywhere from about zero change in unemployment to minus 1.7 based on the data that are in control for the last
Right.
6 years.
The last 8 years, we really have a pretty much a predictable behavior that says unemployment is decreasing at an average of about 0.76, and could be anywhere. I think that's a plus 0.25 down to a minus 1.7 something.
Okay.
So generally, it's decreasing at about 0.75% a year, plus or minus about 1.
Okay. And we could expect that unless something else changes in the system.
Unless something else changes which it might.
Right.
But the only way we will know if something changes is if we get a message.
All right.
And getting a message on a chart is the way we continue to use the data to get a message.
Okay. And so looking forward based on, so there's a number of questions that come up. So we've made a large change to tax cuts in the economic system. We don't know the effect. If it's not significant enough, it'll probably still operate in this realm. But if it is something significant, it's going to make this chart go one way or another because we've actually changed the operational definition of the numbers that are contained here by virtue of the system that has either significantly changed or not significantly changed, and we're waiting for the data to bear it out.
Yeah.
Okay.
Change. It's kind of hard to talk about change in unemployment and have people grasp that. I guess unless you're an economist, because what people feel is actually the unemployment rate. 8.3, 7.6, 5.2, 4.9. Those are unemployment rates that people feel they think in those terms.
Right.
If you are looking at change in unemployment of about negative 0.75, you don't, that could be a change in unemployment is just under a percent change from 10 to 9.5.
Okay.
Or 9.25.
Well, it makes you feel good when it goes down either way.
It does.
And if it goes up, you don't feel as good.
Right.
Yeah.
But you have to be careful about how people don't just look at numbers and understand those numbers completely. People look at numbers and get an emotional reaction to it.
Right, absolutely. And that's where we're trying to put some context around these numbers that gives people an idea of a way to be critical about what they're hearing or looking at or even feeling.
Exactly, which is why I persist in calling this the change in unemployment.
Okay.
That's what it is. It's the change in unemployment.
Okay.
The change in unemployment is negative, meaning unemployment is going down. Okay. And it is going down steadily over those last 8 years.
Okay.
Yeah. Now, the GDP growth that was so much a part of this article, in a way, the GDP growth was definitely higher than it was during the time of the housing crisis and the subsequent collapse in our economy. And the other graph is about GDP growth.
Okay.
GDP growth is the same, the corresponding data for GDP growth that I had in the Okun's law graph is on the process behavior chart for GDP growth.
Okay.
And you will notice the unemployment numbers the change in unemployment went high, the GDP growth went low.
Right. Okay. That makes sense. You would think those would correlate somewhere.
Exactly. Right. And they do as long as you have anomalies going on. Then you'll notice that GDP growth actually settled out starting in 2010 above the average of all the numbers. The average of all the numbers was about where was it? 1.1 45. The average was 1.45.
Mm-hmm.
And 2010 to 2017 were above average.
Yes. And so
So
you put new limits on those.
I
those
did.
data
I
points.
put new limits around those. Exactly.
Okay. And
And
I still can't see that number. Is that 2.10, 2.1
yeah,
something?
it's
Average.
2.1. It's 2.11. I
Okay.
actually wrote it
Okay.
because it's hard to see, and I didn't put a text box around it.
Okay.
I actually wrote it in the verbiage here. The average GDP growth is 2.11, and there are no indications of anomalies at all.
Okay. So we can expect, according to these data, anywhere from that looks like it could be a negative -0.4, couldn't it?
It could.
On
It's
that.
down.
Yeah,
Yeah.
at the bottom there, it looks like negative -0.4, between negative -0.4 and upper control limit of 4.63.
Yes.
We could expect anything in that range, and that wouldn't be considered anything significant unless we got a run.
Now, the reason I get really careful, you're absolutely right. We could expect GDP growth from one December to the next.
Yes, okay, I got you. Based on the operational definition that you gave.
Right.
Okay. The context.
That
Okay.
GDP growth could go as high as 4.6. Or it was the December value, 4.6, or as low as minus 0.4.
Okay.
Just because of fluctuations in the economy.
Okay.
Based on the economic data from 2010 through 2017.
Okay.
So those data values show no phenomenon in there that is indicating GDP growth differences one year to the next is anything but just a noisy system.
Okay. Yep. At this point, based on those data and those operational definitions.
That's exactly right.
Okay. And in this paper, I see, if there's not another point that you're doing, you're talking about correlation and the correlation coefficient between there.
Yes. Yes.
So why don't you explain what you're talking about there?
When people talk about relationships amongst data values, there's a concept called a correlation, and people use it in everyday language. Meaning, when most people say there's a correlation between this and this, I mean, there's a correlation between the outside temperatures in the wintertime and my power bill, for example. Meaning that when it's very, very cold outside, I pay more to the utility company. When it's not as cold outside, I pay less to the utility company. Now, that was, very much true for a long, long time, except in the summertime now, when it is very hot outside, I pay more to the utility company as well. So we have a cyclical kind of thing going on. There is a relationship between outside temperature and how much my utility bill is. These relationships are quantified through the data with something called a correlation coefficient. And a correlation coefficient is a number. It's a dimensionless number, somewhere between -1 and +1. If the temperature outside goes way down and my utility bill goes way up, I have a negative correlation. One number's going down, the other number's going up.
Okay.
If the temperature outside is very, very high, like the summer, 90 some degrees, 100 degrees, and my utility bill goes up as well, then I have a positive correlation.
Okay, that's simple enough.
All right. A correlation of -1 indicates a perfect correlation in the negative realm.
Okay.
A correlation between two things of +1 indicates a perfect positive correlation. Looks like I didn't put anything like that in there. It'd be be helpful. So what I did do is take Paul Krugman's graph, Okun's law, the original data, including the 2 data points for 2008 and 2009, and look at the relationship between change in unemployment and GDP growth.
Okay.
And using those, what you referred to originally as outliers, what I tend to call exceptions or anomalies, or data that are indicative of some other phenomenon going on. Using all the data, the correlation coefficient was minus 0.93. Now, a negative relationship is pretty much what you would hope to see. And it indicates that the change in unemployment, a negative relationship, says that if unemployment changes to the high side, GDP growth will go low. If unemployment change is low, GDP growth is going to be high. So that's what the minus indicates.
Okay.
And it is almost a perfect relationship with those two 2008, 2009 values.
Take them out, and it's not so.
Take them out, and the correlation coefficient between change in unemployment, change in average unemployment, and GDP growth over that time period, those 8 years, is minus 0.13.
Okay.
It's still negative,
right.
Which is not a big surprise. And it is so small that that minus 0.13 suggests that there's essentially no relationship, no detectable beyond the noise relationship between these two variables during
2010 to 2017.
2010 to 2017.
Okay.
That's exactly.
Okay.
Right. Now, one of the things that I think this particular example can illustrate, there's a lot of things it can illustrate in addition to, how do you do a good graph, how you make sure you've got things operationally defined. One of the really key pieces about using data and think about using models in our economic phenomenon is that the underlying circumstances are not stable always. The underlying economy is not stable. So to come out with predictors that are supposedly going to hold across all the possible changes in our economy seems a little bit of a stretch to me. Because the underlying phenomenon, in one sense, we saw the economic housing crisis in 08, 09, and trying to deal with the recovery. A good chunk of that recovery was not just because of the housing crisis, it's because of how the politics played out over the next few years. What decisions people made on how do we recover. And our equations or theories that were developed under different circumstances, I don't know how we can even expect them to apply to these kinds of situations that come up. So there's an issue that I think is something that we can talk about. What are the right kind of ways to analyze data to make sense of it?
Okay.
And then talking about our economy.
Okay. So just to go ahead and land the plane on this analysis, what you've written a summary in the paper. Kind of what's your view then, based on all of this that you found? But I mean, as far as Dr. Krugman's claim that 3% isn't possible. Give it to me straight.
Give it to you straight. Yeah. Here's my straight sense about it. I think that Paul Krugman is brilliant in so many ways. I've read a lot of his work. I don't have any reason to doubt a bunch of his expertise. I think that he is right, because I think the way I looked at the data, that his sense of we're not going to hit 3% GDP growth in the near future is dead on. I think the analyses that he used to get there have some, I question it, the questionable analyses that he used to get there. I think his sense of making the statement we're not going to hit GDP growth of 3% is based as much on his own expertise and understanding of the economy from his standpoint as it was on the data. I think had he used different analyses, a better way of presenting the data, he would have come to the same conclusion.
Okay. Why? Why would he have come to the same conclusion?
Because he said we're not going to hit 3% GDP growth. And when I do the graph, the process behavior chart of GDP growth, I've got the average for the years 2010 to 2017. I write a reasonable prediction of GDP growth for the foreseeable future is 2.11%.
Okay. And again, this is based off of existing, the existing parameters, policies, things within the current system. And what we're talking about are policy changes that may or may not have an effect, and those would be the things that we need to watch for looking forward to see. Now, if you were to look at these data, he's got them rolled up, by year. If we were looking for an indicator faster, would monthly data help us know whether it's growing at a faster rate sooner? Or what types of data might we be able to look at to see, because we're making these big policy decisions all based on theory, right? Yeah. The theory is if we give tax cuts, we're going to get all of this investment back in the U.S. That'll create more jobs, that will grow the economy, and the theory is that it will grow at beyond 3%. How will we know, how based on data, how quickly can we know? Is there a way that we can go about looking at the data to know faster whether we've got a new system going on and it's either having a positive effect, as the Republicans probably would say, or a negative effect or a neutral effect, as the Democrats might say? Yeah. And I don't think it's a Democrat-Republican thing in as much as are we learning?
I think you're right. One of the things that is possible, and you could get these data out of the unemployment figures because we do have those monthly.
Okay.
I have not gone into how GDP growth is collected over a monthly basis. I just look back at the Excel spreadsheet, and I do not see GDP on a monthly basis in the data I actually have. I've got GDP growth from 1990 up through 2017 from one source, but it is annual growth rate. I do not have the monthly growth rate.
Okay. All right. But that is it true or not true that could be a method to help us know at least a little bit faster than year over year if we're tracking monthly data, right?
You're absolutely right.
Okay.
Yeah.
But we may not have weekly data. We may not have daily data, but we might have monthly data.
Yeah. Now here's something that typically happens, and it is a kind of heads up, be aware. Typically, when you go to data collected on smaller time intervals, rather than looking at the annual GDP growth, it's just like a lot of economic data is analyzed using what they call a smoothing approach, where you do your best to kind of dampen down the noisy part of a time series.
Okay.
And when annual growth is going to have a certain amount of noise to it. Inside the annual growth, though, if you look at monthly GDP growth, should we be able to get a hold of that, we're going to have a time series, month to month to month, that probably will have more noise to it.
Okay.
And what happens when you have noisier data, you find it hard to see the signals, the things that would stick out due to some change in the economy.
Okay.
So the whole business of analyzing data is somewhat of a balancing act, particularly as you're analyzing time series, data collected over time. When you're analyzing data collected over time, you're trying to do two things. You're trying to get a handle of what is the background noise to the data we have. What's the basic kind of random component?
Mm-hmm.
And then what is the opportunity I've got to see something stick out that I can understand is a different phenomenon? Because those things that people tend to call outliers in most statistical things are actually the exceptional pieces, the things that actually are worth discussing.
Okay.
Because that's where something's happening.
Okay. And while we're doing this, we also need to be aware of any changes in the way that these things are measured.
You bet.
As we go. So if somebody's out there changing the operational definition of some data points, then that's a whole new system. So we have to have the measurement consistent from not only, and you and I both know from measurements that even if you change the person, sometimes you get a new number.
Yeah.
So assuming that a lot of these data points that come from the government, which would be their original source, is my guess, that they would be pretty consistent. But those are important questions to ask when we're looking.
And I have not actually looked at the technique for calculating unemployment and for calculating the total amount of employment. I'm aware that one of the things we have to be careful about is that some of these data values that we tend to think are connected to one another actually are not in the way they're collected. The origin of the data for unemployment is a separate group than the origin of the data for number of jobs.
Okay.
And I couldn't quote that right now, but it would certainly be a good idea to have that in my hip pocket going forward.
Okay. Well, this has been enlightening.
Okay.
So.
I'm looking forward to getting more of this out and getting better at doing it. Yeah. I think there's a lot of potential here.
Oh, absolutely. Yeah. Well, I mean, everybody has the same question. How do we know that we're operating with good theory, and in this case, good policy?
Yeah.
And how soon can we know so that that you can reroute yourself if you need to, if it becomes bad policy, before things get worse. Now, there's other things at work that could come from left field that could change the system too. So
yeah, I think one of the things that I particularly would find worth exploring are the statistical techniques that have been used in the past to analyze the economic data the right ones to use going forward?
Well, all we have to do there, Frony, is ask 538 because he had the Obama election from 2008 and 2012 down, and then in 2016, just like everybody else, Nate was
bombed on, right.
But that should give us fodder for learning from our mistakes.
Yes.
So.
I know that the business of dealing with the process behavior charts and Schuhart's approach is not a familiar thing for. It's not a familiar thing for most statisticians, much less economists. This is not what most people look at. And so one of the things that I've thought about is what it would be like, and maybe Tripp, this is where we're headed. What would it look like if we had a series called the SPCs of economics?
Yeah. No, yeah. Certainly looking down that that path because the process behavior chart / statistical process control charts shed new light on Krugman's data.
They do.
Yeah,
they do.
Absolutely. Well, this has been really good, Frony, for you to be able to do this analysis because it demonstrates the differences and some of the issues associated with looking at data and drawing conclusions and what we need to understand about changing systems and being able to extrapolate future performance based upon existing systems versus changing systems. And I think that becomes an important piece.
Yeah, it has grown from me getting caught up in a graph that I thought was poorly done.
Hey, whatever the impetus is.
to an analysis that had more in it than met the eye, and then to looking at what does this mean for the next step or the future, or what we can, how do we learn going forward?
Absolutely. Well, we appreciate the analysis. It's been an education.
It surely has. Thanks, Tripp.
Bye.